Adaptive pushover rebuilds the lateral load pattern periodically from the structure's current mode shapes as the analysis proceeds, rather than using one pattern fixed at the outset. As the structure yields and softens, the pattern evolves to follow its changing dynamic properties instead of holding a shape based on the undamaged structure throughout the entire run. 3 specific simplifications in this application. The pattern updates periodically every n steps, not continuously. It applies forces, not imposed displacements, and modal contributions are scaled by participation factor only, with no response spectrum weighting. Like MPA, this method needs the structure's actual mode shapes to compute participation factors at each update. Modal analysis has to be run and saved first. Push direction sets which axis X, Y, or Z, the adaptive pattern is built along. Base shear increment is the absolute base shear added at each pattern update. This is what actually drives the analysis forward, step by step, since the method is force-controlled. Update pattern every n step sets how frequently the pattern is rebuilt from the current softened mode shapes. Smaller n means more frequent updates, tracking the structure's degradation more closely at the cost of more computation. Max total steps is the outer limit before the run stops. This tab shares its middle panel with MPA, so you'll see the mass table still labeled MPA, that's correct. Fill it in the same way, node number, height, and mass for each node. At each update, an eigenvalue analysis runs on the structure's current, already softened tangent stiffness, not the original undamaged structure. For each included mode, the participation factor is recomputed from that current mode shape. Each node's force then combines every included mode's contribution by square root sum of squares, so a node's push force reflects all included modes at once, weighted by how much each one currently participates, not just a single dominant mode. The resulting shape is normalized, so its largest value equals 1.0, then scaled to the current absolute base shear level for that update step. Loads are applied as absolute values held by a constant time series. At each update, the previous adaptive pattern is removed entirely and a new one built at the new base shear level. Exactly one pattern is ever active. There's no overlap or double ramping between the old and new patterns. This is worth stating plainly. The analysis is load controlled since the pattern is defined in terms of forces. Load control can trace the capacity curve up to approximately its peak, but it cannot follow the post-peak softening branch. That's a standard, well-known limitation of any force-controlled pushover, not specific to this implementation. The analysis is expected to stop converging near the peak. If that happens, that's the method working as intended, not failing. Error handling mode in the solver settings is worth enabling here specifically, so the run degrades gracefully into that expected non-convergence rather than halting abruptly. This method prints diagnostic output at every update, current base shear level, each included mode's participation factor, and roof displacement. Watching the terminal while an adaptive pushover runs is the way to confirm the pattern is evolving sensibly, not just waiting for the run to finish. Working order in summary. Run the modal analysis first, fill the mass table, adaptive specific settings, generate and insert the code, and run the analysis.